quick one today. Just going to look at equations which we can turn into quadratic equations, because obviously quadratics easy to solve. So one's like this: polynomials where the pattern, the powers are going up by an even amount. So this one's squared then to the power of 4, or you could have cubed then power of 6 and so on, but we're going up by an even amount. Anything like that we can turn into a quadratic, whether or not you do an actual substitution like I'm doing here. You can say, well, okay, well, let's let m equal x squared, and so m squared is x to the power of 4, and my equation becomes a quadratic. Multiply together to give negative 12, add together to give negative 4, and there's my answer for m. But then we go back and say, oh, hang on a sec, m is in fact x squared, so x squared is 6 or x squared is negative 2, giving us the possibilities plus or minus the square root of 6, or, as far as we're concerned at the moment, no real solutions. Not correct to say no solutions technically, it's no real solutions. So for this one, whilst we're dealing with real numbers, the only answer is plus or minus root 6. These exponential equations, sometimes, I've used parentheses here, you'll notice, but sometimes you'll see them use the dot notation for multiplication. And so it looks like they're saying 4.3 to the power of x. And I have seen people confused in a test where they see it and go, 4.3 to the power of x, how on earth do I solve this? And then they leave it out, okay? It's the dot. Use your logic in something like that. That's why I think this notation is possibly better, because there's no confusion. It's 4 times 3 to the power of x. But again, 9 is 3 squared. So we can turn that into a quadratic. If I let m equal 3 to the power of x, then m squared is 9 to the power of x, and we can prove that quite easily, because 3 to the power of x squared would be 3 to the power of 2x, which I then could rewrite as 3 squared to the power of x, which is 9 to the power of x. I guess all we're really concerned with is just look at the base. If the powers are the same, so the base is the square of 3, so we're fine. M squared minus 4m plus 3, which does factorise nicely. So m is 3, or m is 1, but m is representing 3 to the power of x, so 3 to the power of 1 is 3, and 3 to the power of 0 is 1. Okay.